Hello, everybody. You could probably see by the channel name. I'm Hawk Tutor, right? So obviously that's just a play on words from the popular podcast and from my school, which is pretty interesting, right? So I'm just trying something out, made a YouTube channel. Just going to talk about some derivatives, as we can see right here. We're just going to be going over a couple examples. My mistake with that. So essentially, we're just going to be doing part A, part B, and then I'll briefly be talking about that. So essentially, that's all we're going to be going over in this lesson. But let's get started with part A right here. And yeah, and I apologize for any potentially bad handwriting because I have not done this before, but I'll try to take my time, obviously. So we'll see. All right, but regardless, let's get started with part A. Okay, so essentially we have 5 over negative 5 over 4x to the fourth. We're just going to deal with this first. So we're going to disregard the x squared plus x squared over 2 for now. We're just going to be dealing with negative 5 over 4x to the fourth. So basically, we're going to be wanting to use the power rule for this. So that's just going to be nx n minus 1. Obviously, you have your x, but we're going to rewrite this before we consider the power rule. So the way you want to rewrite it, and I'll try to take my time with this, is going to be 5 over negative 5 over 4. And then we're going to have x to the negative 4 right here. And basically, now we can look at our power rule and kind of piece through that. So obviously you have your x, that lines up, and then your n would be the negative 4 in this case. And obviously I'm just bringing up that 4, so it becomes negative because you're bringing it from the denominator to the numerator, and it goes vice versa as well. If you have a positive exponent or a negative exponent in the numerator, if you bring it to the denominator, it will be negative. So that goes both ways, and right. So we have the n, which is going to be negative 4, and your n in front right here is going to be negative 5 fourths. So basically, we're just going to want to bring that here and multiply it. So we're going to be multiplying negative 4. Sorry if that's hard to read. But we're just going to be multiplying those, and then you subtract this by 1. So essentially, these two 4's right here are going to cancel out. The two negatives will also cancel out into a positive. So you're just going to be left with 5x, and then negative 4 minus 1, negative 5. So 5x to the negative fifth. And essentially, what we have here is another example of what I said before, where you're going to have a negative exponent in the numerator, bring it to the denominator, and it will be a positive exponent. So you're always going to want to simplify as much as you can. Your teacher is probably also going to make that very clear, but you want to simplify, so bringing that down to the numerator is the way to do that here. And that is a 5. It looks like a 3, but it is a 5. So 5 over x to the fifth is going to be your derivative for this part. And now we're going to get into the next part, which is x squared plus 2. This one's obviously a little bit easier visibly. So we're going to have x squared over 2. And what you want to do here is assume there's a 1 in front of that x, because theoretically there always is. And then you're going to want to do 1 half x squared. So same situation, we're using the power rule. Your n is going to be that 2, and you're going to bring it in front and multiply it. So now you have these two canceling out, and you subtract that by 1, so you're just left with x. Because obviously those two cancel out, and then you're subtracting it by 1, so all you're left with is a bare x to the first, which is just x. So now I'm just going to erase a little bit of this, and now we can see our answer for part A, which is going to be this plus x. So that is what you get for this. So obviously we just use the power rule for each of these separately. If you see that plus in the middle, you're going to want to use the product rule. Not the product rule. That's the next one. But the power rule separately for both of those. So that's what you're going to do there. And speaking of that, which I just mentioned accidentally, we're going to be using the product rule for this. And it's not mentioned up here, but I'm going to draw it out for you guys real quick. If you have u times v, and for context, this 6 radical x is going to be u. The other piece is going to be v. So that's what we're going to be considering here. So that equals u prime, which is just the derivative, u prime v, plus u in general, so just that u function as a whole, times v prime. So that's the derivative of v. So I'm just going to leave that up here. We're going to box this in just so that we can always keep that in mind for this problem and future product rule problems. So essentially, we're going to find the derivative of u first, just so that we can start off the product rule. So we're given 6 radical x, and all you're going to want to do here is take that x, and anytime you see a square root, all that's going to be is raising it to the 1/2 power. So the square root is indicative of the power 1/2. And then from here, once you have this, it's the same deal with the power rule. So you're going to want to apply that again, where you're multiplying that 1/2 right in front. It's going to be hard to draw here, but you're multiplying the 1/2 in front. 1/2 times 6 is going to be 3, 3x, and then 1/2 minus 1 is going to be negative 1/2. So basically, when you have that negative 1/2, you're going to leave the 3 up top, bring that x to the denominator, because remember, if you have a negative in the numerator, you're going to want to bring that to the denominator. And then because it's 1/2, you're going to want to do the square root of x, because it's 1/2, and we just obviously had this radical right here, which we turned into 1/2, so it goes both ways once again, where if you have that 1/2, you can turn it back into a square root. So that's why the derivative of u here is 3 over radical x. And now we can take that for u. So we have 3 over radical x times v, in this case, is times 2 radical x minus 3. So that's going to be your first part. So in context, that's just this. And now we're going to solve for this. So you already have. You don't have to do anything to that. So you're going to add. You can just leave that as 6 radical x. Completely leave that. But now we're going to find the derivative of this. So we have 2x in a radical. Once again, we're going to make that x to the 1/2 and apply that power rule again, where you multiply that 1/2 in front of that 2, which those 2's are going to cancel out, and you're left with x to the negative 1/2, which is essentially just going to be 1 over square root x. We're applying that same exact concept as before. And this minus 3 right here, right there, you're going to want to disregard that, because we're going to use the constant function rule for that, where if you just have a constant standing alone, it's going to be 0. So that's just disregarded. So essentially, all this is 6 radical x times 1 over radical x. So now, from here, I'm just going to erase a lot of this real quick so we can get a more clear visual. So from here, all you're going to want to do is simplify by distributing, multiplying these together. So from the first one, we're going to get 6 radical x over radical x. Right, so we get 6 radical x over radical x. And from here, we can just get rid of those radical x's, and we're just left with 6. So essentially, we just have 6. And then minus 9 over radical x. Of course, from the other part of that problem. So my 3 over radical x times negative 3. So it's going to be minus 9 over radical x. So that's essentially all that's going to be. So this right here in parentheses is your first part, and I'm just going to erase this for clearness sake. And now you're going to want to do the second part, so plus, and then we have 6 radical x over radical x. So we have 6 radical x over radical x, and essentially you're going to want to cancel that out, and you're left with plus 6. Essentially, if you just want to remove those parentheses and simplify, it's this plus 6. So that's what you have right there. And then we can simplify even further and add those 6's up, and we end up with negative 9 over radical x plus 12. So that's going to be our final answer. Essentially, you just do those processes, and it makes it a lot easier if you can split up your work. And I'm just going to take all that down, but if you need to rewind, go ahead. So essentially, you're just going to split up everything and then apply whether it's the product rule, which is that, or just your power rule right there with these. So if you see something like this, right here, I'm referring to A. Don't get intimidated. All you have to do is essentially just break it up and solve for each separate derivative. In something like this, once again, don't get intimidated. There's a formula for it, which is right above. And now I'm just going to talk about this for a little bit. This is going to be brief because if you want to apply this further with, let's just say you have e to the negative x, you're going to want to use the chain rule, which I'm not going to discuss in this video. I'm going to save that for a future one. But for now, we're just going to be talking about e to the x as a base function. So we have d over dx, e to the x, simply equaling e to the x. And this is pretty much what it looks like. If you have e to the x, the derivative of that is going to equal e to the x. So if you see that e to the x, you already know the derivative is just going to be the same thing. And that's kind of that main concept with that, where it's not necessarily something you have to solve. It's just more something you have to memorize, where you just have to know if you see this, it's going to be that when we're talking derivatives. So essentially, this is more that one of those memorization components where you're just going to want to get that down and not forget it. So I would highly recommend making sure you have this down and keep it established in your head, because that is very important for a lot of different applications, like the chain rule, where, like I said, if you have something like e to the 3x, it's not simply just e to the x. Obviously, you have to apply the chain rule, which I'll go over later. But in this video, I just kind of wanted to explain how to find basic derivatives and apply some of the rules. So that's going to be it for this video. And if you enjoyed, please consider subscribing and liking the video. Even if you found it helpful, do that as well. And yeah, I'll see you guys in future videos, but see you for now.